So welcome. We are now beginning Unit 1, Lesson 8. And the learning target is I can rearrange formulas to highlight a quantity of interest using the same reasoning as in solving equations by using various mathematical practices. So in this lesson, you'll be solving for variables that have other variables in the equation, still using inverse operations, combining like terms if possible, and doing the distributive property if needed. But let's first just stick with solving equations with one variable and just practice that. So we have for the do now, 3 divided by 6 equals x minus 3 divided by 8. So in order to get rid of, when you solve proportions, you have to cross multiply. So we have 6 times x minus 3. Whenever you have a term that is an expression like we do here, x minus 3, you want to keep that term in parentheses to show that that is stuck together. So when you write 6 times x minus 3, you have to keep the x minus 3 in parentheses. Then it equals 3 times 8, which is 24. Now to get rid of parentheses, you multiply and distribute. 6 times x is 6x, and 6 times a negative 3 is a negative 18, equals 24. Now we need to get the x alone, so you always want to move the term that is being added or subtracted to the variable first. So we want to move this minus 18 over by adding 18 to both sides, and now we're left with 6x equals 42. And then our last step is always to do division if it's attached by multiplication, and we have x equals 7. Same thing here. We have to use cross multiplication to get rid of proportions. So we have 4 times x minus 2. Again, you have to keep x minus 2 together because that is one term, so you put that in parentheses. Equals 8 parentheses x plus 2. You have to do the distributive property on both sides. So 4 times x is 4x. 4 times a negative 2 is a negative 8. Equals 8 times x is 8x. 8 times 2 is 16. We have variables on both sides. Whenever you check and you have variables on both sides, you want to move them together first. So I'm going to move the 4x over to the 8x. And I'm going to do that by subtracting 4x because I need to use the inverse operation since it's on the opposite side of the equal sign. So when I subtract, I have negative 8 equals 4x plus 16. Now I look for the variable. The variable is over here. It has a plus 16 attached to it. I need to move that away because I don't want anything attached to the variable. So I need to move the 16 over by subtracting 16 on both sides. And when I do that, I have negative 24 equals 4x, and divide by 4 on both sides, and I have x equals negative 6. There's a negative divided by a positive is a negative answer. And lastly, we have 12 times x plus 2. We're going to write 12 times x plus 2, and then we have to do 6 times x minus 1. Equals 6 times x minus 1. And so when I distribute, I get 12x plus 24 equals, now I distribute the 6. So this x is 6x, and 6 times a negative 1 is a negative 6. Minus 6x on both sides. And I'm left with 6x plus 24 equals negative 6. That negative sign is still attached to that 6. Now I need to move whatever is being added or subtracted to the variable first. So I minus 24, and I'm left with negative 6x equals negative 30. And now I have to divide by negative 6, divide by negative 6, and x equals 5, because a negative divided by a negative is a positive, and 30 divided by 6 is 5. Okay, so a literal equation is an equation involving two or more variables. So it has to be two or more different, I'm going to add that keyword, different variables, because we have worked with equations that have had two or more variables, but they were the same. So now they have to have two or more different variables. So with that being said, an example would be 4x plus 2y equals 18. Right there, we see an x and a y. So that would make it a literal equation. So when we solve literal equations, we are going to solve them the same way we would solve for just an equation like we've seen here with one variable. So I have here two equations set up with the same operations, but instead of having a 2x, we have an ax, and instead of a 4, we have a b. So I'm going to show you how we would solve for, say, x in the equation with all variables, as well as an equation when we've seen it with just numbers, okay? So if we had 2x plus 4 equals 12, our first step is always to move whatever's being added or subtracted to the variable we are solving for away first. So I'm solving for this x. So I want to move this 4 over by subtracting 4 and subtracting 4. So we get now 2x, and we can actually do 12 minus 4 because they're like terms and get 8. The difference here is we are still solving for x. You still want to move whatever's being added or subtracted first. So the same way we would subtract 4 to use the inverse operation to cancel out the 4, we need to use the inverse operation to cancel out b. So if it's a plus b, we're going to subtract b. And again, what you do to one side, you would do to the other. But just because it's a letter doesn't make it different. You're still using inverse operations, and you're still moving it over to the other side to get the variable you want to solve for alone. So on the left side, you're still left with ax equals. Now 12 minus b we cannot do because they're not like terms. One's a 12, which is a number, and b is a variable. So since they're not like terms, you're just going to leave it as 12 minus b because you can't solve it. So you have to leave 12 minus b. Now let's go back over here. We have to divide by 2 because the 2x is attached by multiplication, and the opposite of multiplication is division. And you want to divide by whatever is not the variable you're solving for. So 2 we don't need, so we move it to the other side by dividing. And we're left with x equals 4 because 8 divided by 2 is 4. Same thing here. We have ax. Two variables now, but again, they're attached by multiplication. And the opposite of multiplication is still division. And now you're still going to divide by whatever is not the variable you're solving for. So a is a variable, but it's not the variable you're solving for. So we need to divide by a to cancel it out over here and move it to the other side. And when you divide by a, the whole side is getting divided by a. Not just 12, not just the negative b, the whole entire side is getting divided by a. Now, I cannot break this up because, first of all, 12 and a are not like terms, and negative b and a are not like terms. So you just leave your answer just like that, as 12, x equals 12 minus b divided by a. And that will be your answer. There's no terms that can be simplified. There's no terms that can be combined. That is its simplest form. So you still use inverse operations. You still want to do the addition or subtraction first, then do the multiplication and division. Okay? So describe the operations we use. Like we just said, we used inverse operations. And describe what terms we were able to combine and simplify. And our answer, when we're solving a regular equation with one variable, will have x equals a number. When you are solving a literal equation, you're going to have x equals some expression. And the expression is 12 minus b divided by a. So Solving for a variable when given more than one variable. To solve for a variable that you would treat the other variables as if they were constants and coefficients until you have the variable you are solving for alone. That is always the key. Whatever variable you want to solve for has to be alone on one side of the equal sign. So solve for y. So here is y. Y is on this side of the equal sign. So what is attached to it that I need to move? What is attached to it is z. Y and z are attached by multiplication. The inverse operation always in multiplication is division. Divide by whatever is not the variable. Z is not the variable you want to solve for. So you got to move the z over by dividing it on this side to cancel it out, and instead moving it and dividing it by here. So y equals x divided by z. Done. There's no other steps. Y is alone. Y was what we wanted to solve for, and it's equal to this expression, x divided by z. Same thing here. We want to now solve for x. I'm going to circle the variable we're solving for. Here's this equation, 2xy plus z equals 4. Your first step always is to move the number or move the term that is being added or subtracted to the variable you are solving for first. So we have this plus z. I need to move that over. So the opposite of plus z is subtract z. Subtract z from both sides. And you're left with 2xy equals 4 minus z. I cannot subtract z from 4. They're not like terms, so you just rewrite it as 4 minus z. Now, 2xy are all attached by multiplication because they're all connected that way, and multiplication is commutative. So we are going to divide, because that's the inverse of multiplication, by any term that is not x. So in this case, 2 is not x, and y is not x. And I can divide by that because they're all attached by multiplication. And I get the 2's to cancel out and the y's to cancel out. And on this side, I will divide by 2y. And so, your final answer, you just rewrite because nothing is the same. There's no like terms, so you just leave it as x equals, which is our goal to get x and solve for x alone, equals 4 minus z. Now in the denominator we have 2y. Done. That is what x will be equal to. So we're going to do a couple of these, and then I'll have you try it some on your own and then check your answer. So I always like to circle what I'm solving for here. I'm solving for x. So it's attached to the 5. I need to get the 5 over by using division because it's multiplication. So when I divide by 5 on both sides, I'm left with x equals z divided by 5. Done. Now I have 2 plus x. Again, we're solving for x. X is attached to this 2 by plus 2. So the opposite of a plus 2 is a minus 2. You subtract 2 from here to move it away from the x, and you subtract 2 from the other side. And we're left with x equals, we cannot combine a y and a negative 2, so just leave it as y minus 2. You're done. Again, we are solving for x. Z is attached to the x by multiplication. The opposite of multiplication is division. Divide by anything that is not x attached to it, which is just z. So we cancel the z's here and divide the whole other side by z. So rewrite your answer as x equals 5y divided by z. And that's it. For the next one, again, we have the 3x. 3x is attached by multiplication, so divide by 3 on both sides, and you're left with x equals 2y divided by 3. Done. Here, we have to solve for x. We want to move this whole term over. It's attached by addition. So in front of this is a positive 4y. So the opposite is now minus 4y. So we cancel it out from here and minus 4y from the other side. And just rewrite x equals w minus 4y. This next one is a little bit different than what we've seen. Again, we have to solve for x. 9x, y, z are all attached by multiplication. So we can do the inverse operation and divide by everything that is not x. So we're going to divide by the 9, divide by the y's, divide by the z's. So the 9 cancels out, the y's cancel out, and the z's cancel out. Now on this side, I have to divide by the same thing, 9yz. Now, you can simplify some terms here because you have 27y is attached by multiplication and 9yz is attached by multiplication. So we can actually divide 27 divided by 9 is 3, and then the y's will cancel out. So we don't have any y's left in our final answer. And then we're left with, still in the denominator, z. You can't forget about that z. That z is still there in the bottom, so it stays in the bottom. You don't bring it to the top. If it's in the denominator, you'll keep it in the denominator. But we can just do 27 divided by 9, which is 3. A whole number goes in the top. Next one, we have to, again, solve for x. So we need to move whatever is being added or subtracted first. So we need to move the plus z, so we move it over by subtracting z. And subtract z. Y and z cannot subtract from each other because they're not like terms. So we're left with wx equals y minus z. Now we need to divide by w to get x alone, and divide by w. And here, there's nothing that can be simplified because none of them are like terms. They're just going to have x equals y minus z divided by w. Next, we have 3wx minus y equals 6z. So here's our x. We need to move any term that's being added or subtracted, which is the minus y. Move that first by adding y to both sides, and you're left with 3wx equals 6z plus y. Now I need to get x alone, so I have to divide because they're all attached by multiplication. So I'm dividing by the 3 and dividing by the w because they're not the variable I want to solve for. And then this side I divide by the 3 and the w. So you just rewrite it as x equals 6z plus y divided by 3w. And that will be your answer. And these are literal equations, so your answers will be in terms of other variables. And the fast finisher is negative 2x equals 3/8 a literal equation? No, it's not, because it does not have 2 or more variables. Okay, so now we're integrating our knowledge of equations and geometry into solving for different parts of the equation. So first, let's just start by writing a formula for the perimeter of a rectangle. And we know that the perimeter is adding up all sides. So we could write the perimeter equals of a rectangle, one length plus the other length plus w plus w. Because this side is represented by w and this side is represented by w. Now, I have like terms that can be combined. So I'm going to combine the L and the L, which we know combines to be P equals 2L. And then I have the W and a W equals 2W. So my perimeter for a rectangle would be 2 times the length plus 2 times the width. Part B, solve the formula for W to get W alone. So I'm going to rewrite my equation. I have P equals 2L plus 2W. I need to solve for W. So you want to add or subtract a term that is being added or subtracted to it. 2L is being added to the 2W. So we need to move the 2L first by minusing 2L on both sides. Minus 2L. P and 2L cannot be combined. So we just write it as P minus 2L equals 2W. Now, in order to get W alone, we need to divide by whatever is not W, because they're attached by multiplication. So we divide by 2 and divide by 2. So the new formula to solve for W will be W equals P minus 2L divided by 2. We just solved for W. We got W alone, and it's in terms of all the other variables that we have. Now use the new formula to find the width. And we will use the new formula because the new formula is equal to W, which is the width. So we have W equals P minus 2L divided by 2. We see here in our diagram, the perimeter is 19. The length is 5.5. So when we have to solve for missing pieces of information, we use substitution. So we know P, so we're going to substitute P with 19 minus 2, and L is 5.5. So we're going to replace L with 5.5. Wherever we saw the P, we had to replace with 19. Wherever we saw the L, we had to replace with 5.5. So, and then you still have divide by 2, and then you could type that directly into your calculator, and you get W equals 4 inches. And that's your answer for that one. Our next question is we have to write a formula for the area of a triangle. The area of a triangle is 1/2 base times height. So here we have this fraction, and we have it base times the height. They want us to solve for h. So I'm going to rewrite a equals 1/2 base times height. So first I'm going to get rid of the h. Actually, I'm solving for h. Never mind. I want to get rid of the b that's attached to it. So I'm going to divide by b on both sides. And now I'm left with a over b equals 1/2 h. Now remember, whenever you have a fraction attached to a variable, you get rid of that fraction by multiplying by its reciprocal. And remember, the reciprocal is the fraction flipped, because then it gets all the numbers in the fraction to cancel out. The 2's cancel out and the 1's cancel out. And then what you do to one side, you do to the other. So you multiply that whole side by 2 over 1 as well. And so you have h equals, now we know 2 times a will just be 2a, and 1 times b in the denominator is just b. So this was your new formula to solve for h. And now using the new formula, like we did in the previous problem, we're going to substitute in values to help us solve for h. So I'm going to rewrite my formula, and now I'm going to substitute. They tell me a is 10, so I'm going to replace a. So 2 times a is 10, and then I'm going to replace b with 5 over 2. And if I was you guys, I don't like putting a fraction into a fraction that's already there. So I'm going to change this 5 over 2 and make it a decimal, and you could type that into your calculator, click enter, and it should give you a decimal of 2.5. So I'm going to use 2.5 for B instead of 5 over 2 because I like decimals better than fractions. So when you, again, write this into your calculator, you get H equals 8 inches. And now you just solve for the height. Here's another one. Now we're talking about a circle. So a circle has a circumference that is going to be C equals 2 pi r. Now, we're going to use this formula and not the circumference formula, pi times diameter, because they're giving us, if you look at your picture, the radius, and they're asking us to solve for r. So we need that variable r in our equation. We could have used 2 pi times diameter, but that's not the variable we need. So when you are going to solve for an equation, make sure the variable you need is in it. So here we now have 2 pi r, and we're ready to solve for r. So I'm going to rewrite C equals 2 pi r, and I have to now use division because 2 pi r are all connected by multiplication. So I'm going to divide by anything that's not r, which is the 2's and the pi, to cancel out, and I divide it by the other side as well. So r equals C over 2 pi. And again, we're going to use the information they give us to substitute into our equation to solve for r. So r equals, C we have is 8 pi. So when they give it to you, when they tell you a term is in terms of pi and pi is in it, you're going to use that. You do not leave the pi out. So the whole term C is 8 pi. And in the bottom, we still have 2 pi. There's nothing to replace in the bottom. So here, pi divided by pi, they cancel each other out. So all we're left with is 8 divided by 2, which is the radius of 4 centimeters. And I'll make sure you always give it its label as well because it's talking about a measurement. So here was centimeters, so you know to answer your answer in centimeters as well. Okay. So with these, we're going to make sure, I'm going to let you try these on your own, and then you can come back and see if you had got them correct and check your work. Just remember that when you are solving, you are still following the rules for solving equations. So if there are parentheses, you can still, you don't need to get rid of them, but you could, but you're just making it harder for yourself if you wanted to, okay? Just take it one step at a time. So for the first one, we could distribute 4 times r is 4r, and 4 times 3 is plus 12, equals t. We have to solve for r, so we want to move the plus 12 over first, because we always do the addition or subtraction first. Minus 12 from both sides, and we're left with 4r equals negative t minus 12. Divide by 4 to get r alone, and we're left with, I'm sorry, I don't know why I put that negative t. It should not be a negative t. Typo on my end. So 4 equals t minus 12, r equals t minus 12 over 4. Here you could simplify this by doing t divided by 4 is just going to stay as t divided by 4, and you can simplify negative 4 divided by 12, negative 12 divided by 4 is negative 3, and that would be your answer. R equals t divided by 4 minus 3. For the next one, we have to solve for w. So we need to move the 2L first because it's being added to the 2W. So we move it over by subtracting 2L, and 2L minus 2L is canceling out here, and we subtract it from the other side. So we are left with P minus 2L equals 2W. We need to divide by 2 to get W alone. And we're left with P. We could simplify this one as well if we want. P divided by 2 minus 2L divided by 2. The 2's cancel out, so you're left with just minus L equals W. Over here, we have to solve for W. We haven't seen anything like this yet, but again, if we have a W on each side of the equal sign, the goal is to get them together first, okay? Because we should never have two of the same variables within the equation. So we like to bring the smaller over to the larger, and we always need to use the inverse operation. So this is a positive 2W, so we need to minus 2W. And then we minus 2W from 7W to get them together. And we're left with negative y equals 5W minus 2. Now we need to solve for W, and we need to get it away from that negative 2. So we need to move that over by adding 2 on both sides. And we're left with 2 minus y equals 5W. And we divide by 5 to get that W alone. And we're left with W equals 2 minus y over 5. Because there's nothing to simplify here, okay? Over here, we're solving for x, so we need to move this negative 16W, the 16W over by minus 16W on both sides. And we're left with 4x equals y minus 16W. We need to solve for x, so divide by 4, and you can simplify this by breaking it apart. Y divided by 4 equals y divided by 4, because that cannot be simplified, but negative 16 W divided by 4 is negative 16 divided by 4 is negative 4, and then we just leave the W attached, so that is our answer. The W does not cancel out because there's nothing to cancel it out with, so you just leave it attached to whatever the math of negative 16 divided by 4 is. For next one, we have to solve for x. So we have this negative t, we have to add t on both sides, and we're left with 2p plus t equals kx. We have to divide by k, and 2p plus t divided by k equals x. Here we're solving for s. So we need to move this negative 5g over by adding 5g to both sides. And we're left with 9s equals negative 4u plus 5g. Nothing can be combined. That's a u and a g. Here, last step is divide by 9. S equals negative 4u plus 5g divided by 9. And we don't need to divide each term by 9 because they are not going to be simplified. Negative 4 and 9, and 5 and 9 are not going to simplify to any other number. Fast finisher, we have to solve for h. So we want to get rid of whatever is in this denominator first. So the denominator, this is a division problem. So we have to get rid of the 2 by multiplying by 2, because the opposite of division is multiplication. Divide by 2. So we have 2a, and if it's a large A, keep it a large A, equals h times a plus b. We want to just solve for h. So a plus b, when it's in parentheses, it's in a whole term. It's stuck together. So you want to move this whole term by using division, because a plus b, the whole thing is attached to h by multiplication. And the opposite of multiplication is division. And a plus b stays together. So yes, there is a plus sign, but it's attached to this h by multiplication because we know parentheses means they're multiplying. So if we just divide by the whole a plus b, it cancels out that whole term, and we're left with 2a over A plus B equals H. And that would be our final answer for this question. Okay, moving on, we have an error analysis, real world question first. So bricklayers use the formula N equals 7LH to estimate the number of bricks needed. So bricks is the N, represented by N. Oops. To build a wall of H height. So H is your height, N is the number of bricks, given an L length, and L is your length in feet. Transform the formula to solve for the height, which is our H, in terms of the number of bricks. So we're going to just solve for H now. So we rewrite N equals 7LH. 7LH is all attached by multiplication. The opposite is division. Divide by everything that is not H, which is the L and the 7, and divide the other side by 7 and L. So H equals N divided by 7L. So what is the height of the wall? That is 30 feet long, so that's our L, and requires 2,135 bricks. So our key, if you wanted to make a key, I always suggest a key, L equals 30, and N equals 2,135. So using our formula, H equals N divided by 7L, we're going to substitute. N is 2,135. We still keep the 7 and multiply it. When we substitute it, remember you always substitute with parentheses, is 30. And you could type that right into your calculator and you'll get a decimal that, so H equals 10.16, and 6 is repeating, so you put the line over it and make sure you give it its label, which is 10.16 feet. And that is your answer to that one. Find the error. Bill and Sam are solving the equation 4A minus 5B equals 7 for B. Is either of them correct? Explain. So take a minute and see what you can come up with. So after observing this, we know, the way I like to check for an error analysis is I like to do the problem myself and see what I would get, and then compare my steps to the steps in each of theirs. So I need to solve for B. So I'm going to solve for B here. So that means I need to move the 4A first by subtracting 4A on both sides. So I subtract 4A, and I'm left with negative 5B equals negative 4A plus 7. So let me check. From here, I have 5, I'm going to check Sam first. So I have 5B equals 7 minus 4A. That is not correct because the 5B should be a negative 5B, because that negative sign that's in front of the 5B stays with the 5B. So right there, Sam is incorrect, but let's check Bill's work. When they subtract 4A on both sides, he keeps the negative 5B, perfect, and he has 7 minus 4A. Remember, addition is commutative, so the way I wrote it over here as negative 4A plus 7, it could also be written as negative 5B equals 7 minus 4A. The 4A is still with the negative sign, and the 7s are still positive. So that's correct. Then my next step would be to divide by negative 5 to get B alone, divide by negative 5, and I'm left with B equals 7 minus 4A over negative 5. So let's just check if Bill continues to solve correctly. He divides by negative 5 on both sides, and his answer is the same as ours, which is correct. Sam, we had found that he left out his negative sign, but he followed through with the rest of it correctly by then dividing by 5, but he should have kept that negative sign there. So Bill and Solve, did any of them solve correctly? Yes, Bill did. So yes, Bill. Sam forgot the negative sign. Okay, so here we have this last few questions here. We're going to solve for R. So we have E equals I over R. So we have to divide by I to get R alone. And we have R equals E over I. So we have that the formula for Ohm's law is E equals IR, where E represents the voltage, I represents the current in amperes, and R represents the resistance. So there's our variables. So down here, suppose a current of 0.25 ampere flow. Ampere is represented by I, so on my key, I'm going to have I equals 0.25 through a resistor of 12 volt battery. So R equals 12. I'm sorry. The resistor is connected to a 12 volt battery, and we know the voltage, is represented by E. E is your voltage. Right here is the voltage that represents E. So here 12 volt battery is your E. So when I substitute in, I have R equals E over I. E is 12. I am replacing a 0.25. And when you put that into the calculator, you get R equals 48 ohms. So for this question, in a uniform circular motion, speed v of a point on the edge of a spinning disk is v equals 2 pi r divided by t, where r is the radius of the disk and t is the time it takes the point to travel around the circle. So solve the volume for r. So I took the equation, it was v equals 2 pi r over t. T is in the denominator, so you have to use multiplication to undo the division. So you multiply each side by t, and you're left with TV equals 2 pi r. Now to get the r alone, which is our goal, I divided by everything that's not r, which is 2 pi. And I now have to divide this side by 2 pi. So here the 2's and the pi's cancel out, and I'm left with r equals TV over 2 pi, which is our answer here. So now we're going to use that formula. Suppose a merry-go-round is spinning once every 3 seconds. So right there, I know that that's talking about time. So I wrote t equals 3 in my key. And on the outside of the edge, it has a speed of 12.56. And I know speed, they told us here, was represented by v. So in my key, I'm going to write v equals 12.56. And they're telling me to use 3.14 for pi. So I'm going to change pi to equal 3.14. So I rewrite my formula, r equals TV divided by 2 pi. And that equals, I substitute in 3 times 12.56 divided by 2, which stays, and substitute 3.14 in for pi. When you type that into your calculator, you get r equals 6 inches. For the next question, we have the volume of a box V. So now we're talking about volume, and that's represented by V. It's given by the formula V equals LWH, where L is the length, W is the width, and H is the height. Solve for H. So we have our formula, V equals LWH. I'm solving for H. So I'm going to use the inverse operation of division since they're all attached by multiplication. I divide by whatever is not H, which is W and L, divide by L and W. So H equals V divided by LW. And I'm going to make my L like this because otherwise they kind of look like ones. So that's a script L I'm going to use, okay? And that would be h. Now, what is the height of the box? So we're solving for the height. What is the height with a box with a volume of 50? So again, for my key, I have V equals 50, L equals 10, and W equals 2. So the length of 10 meters and the width of 2 meters. So I write H equals V over LW. Now you substitute in. H equals V is 50 divided by L is 10, W is 2. So go ahead, substitute that into your calculator, and you get H equals 2.5 meters. Here is a Regents question. So the distance of a free-falling object has traveled can be modeled by the equation d equals 1/2 at squared, where a is the acceleration due to gravity and t is the amount of time the object is falling. What is t? So we have to solve for t in terms of a and d. So that means you're going to solve for the letter t, and a and d are going to be in your answer. They're your other variables. So we have d equals 1/2 at squared, okay? So we're solving for t. First thing we want to do is get rid of this fraction. And we know that when we have a fraction attached to a term, you multiply by its reciprocal to get rid of it. So I'm going to multiply the whole fraction by the whole term by 2 over 1, and multiply this side by 2 over 1 to cancel out that fraction. So 2 times d is just 2d equals at squared. So still, this t squared has this squared attached to it. So we're going to leave that alone first, but we still have this a. We have to move this a over by using division, because a and t are attached by multiplication, so we need to use division. So we divide by a to cancel that out on this side, and then divide by a on this side. So we're left with 2d over a equals t squared. Now the inverse operation of squared is square root. So the way we would undo addition with subtraction or undo division with multiplication, we undo squared with the square root. So we have to take the square root of t squared. So now the t squared, the square root will cancel out, and we have to take the square root of this side as well. So our final answer is t equals, because we cancel out the squared with the square root of td over a, which is answer choice B. Last but not least is our exit slip, which was again another Regents question. So the formula for converting degrees Celsius to degrees Fahrenheit is F equals 9/5 C plus 32. Which expression is correctly written to convert Fahrenheit temperature into degrees Celsius? So what we are going to start by doing is write down the equation. Start with F equals 9/5 C plus 32. We want to solve for C. So if there's a term being added or subtracted, you have to move that first. So we have a plus 32, so we minus 32. So cancel it out over here, and we minus 32 over here. So we're left with F minus 32 equals 9/5 C. Now, we need to get rid of this fraction attached to a variable. Again, to get rid of a fraction attached to a variable, you multiply it by its reciprocal, and it will cancel out the 5's and the 9, which gives us, then we have to multiply this side by 5 over 9. Now, this whole side right here is one term. So we're going to put this whole thing in parentheses since this whole side is being multiplied by 5/9. Okay? So remember, if a whole term is being, there's a number and a letter attached, we have to keep them together by using parentheses. So now we have 5/9. I'm going to rewrite it over here. And we have f minus 32 equals c. So obviously in our answer choices, they got rid of the parentheses. So we have to distribute the 5 to the f and the 5 to the negative 32. And we know that anything that doesn't have a denominator is always over 1. So we just have to multiply the 9 times the 1 in the denominator. So 5 times f is 5f, and 5 times a negative 32 is negative 160. And then 9 times 1 in the denominator is just 9, which equals C. So that is our answer. And which is answer choice C. Okay? So that you would just match with whatever was left there. And that is the end of this lesson. Actually, I didn't realize there's 2 more exit slips. So we're going to actually finish solving these. So we have 2. For this exit slip, another Regents question. The formula for electrical power P is P equals I squared R, where I is the current and R is the resistance. The formula for I in terms of P and R is what? So we have to solve for I. So we're going to write our formula P equals I squared R. So wherever that squared is attached to the I. So we are not going to do anything with that yet. But we do have to isolate the variable. So we have I is attached to R. So we are going to use division because they're attached by multiplication to get rid of the R's. And we divide this side by R, and we're left with P over R equals I squared. So again, we have this squared. The inverse of squared is square root. So we take the square root to cancel out the squared, and if we have to take the square root of the other side as well. So our final answer is I equals the square root of P over R. Lastly, we have one more Regents question. Exit slip number 3. The formula for converting degrees Fahrenheit F to degrees Kelvin K is K equals 5/9 times F plus 459 plus 67. So F, we have to solve for F. F is in those parentheses. So we need to first, we can't move anything inside the parentheses until we get rid of this 5/9. You want to move whatever's on the outside first. So this 5/9 is attached to this whole F plus 459.67 by multiplication. And it's a fraction attached to a term by multiplication. Again, you get rid of a fraction by multiplying by its reciprocal. So we're going to multiply this whole side by 9/5. Remember, reciprocal is flipping the fraction to get the 9's to cancel out and the 5's. And what you do to one side, you do to the other. So we have to multiply this side by 9/5. So now 9 times k is 9k divided by 5 equals, now we're just left with f plus 459.67. Now we have to still solve for f. It's attached to this plus 459.67. So we have to minus 459.67 from both sides. There's nothing to subtract that from, so you're just going to rewrite it as F equals 9k over 5, because they're not like terms, minus 459.67. And that is F in terms of k. So that means k has to be in your answer. And now we are done with the lesson.